Welcome, everybody, to the AI Engineering Bootcamp session 14. Today, we're talking advanced agents and reasoning. It's a great week to talk about this, and there's been just so much happening, even in the past month, that it's really come together in a nice, crazy, big session that we are really aligned towards truly grokking the LLM edge today. So I hope that you guys enjoy the session and the show today. We've got a good one for you. But a couple quick shout outs to the folks that were building, shipping, and sharing last week and then getting out in public, doing the thing. Ashwin, of course, keeping it going. Balanced news perspective. Oh, that sounds familiar. That's right. He just shared it in class last week. He's sharing the app this week on LinkedIn. That's the way to do it. Shout out to Anthony Chapman, my man Anthony. First share. Shout out to Anthony. Smash the chat. Congratulate Anthony on his very first share. Love to see this. It's always the hardest one. Way to go, my man. Looking forward to watching the journey from here. And of course, Ben keeps sharing his VR worlds. They're getting a little bit more refined, a little bit more robust, a little bit more interesting and cool. Very cool stuff. I look forward to seeing more of you guys build, ship, and share as the demo day projects start to come to fruition. Homework number 10 coming back to you. Fine-tuning LLMs. We've got still solid submissions, solid perfect scores. Duke, why don't you tell us what you saw overall and what you thought of everybody's work?
Overall, I think most students do a very fantastic job breaking down the fine-tuning process. So I think it's great to see many clear explanation with a strong attention to the technical and the reasoning behind each step. I think the presentation is super solid. They working through all the concept very well, and also shared a very useful insight from their own experiment. Um, I think this assignment is very technical, so some students still struggle to make it work, and they have some error to load the model. I mean, I read one comment from a student say the material is so dense, so I want to learn more, but I also never want to learn about this again. So yeah, so this is very
Oh, nice. Good
very
stuff.
stuff. Yeah.
Great stuff, man. And you know what? I think that's really interesting, especially considering that we're actually going to move that stuff out and into the front. I'm actually trying to move it either into onboarding or the application process for cohort 6. So you guys are some of the last ones through, I think, before this really became kind of table stakes. You guys are doing a great job with this. The lessons learned, PEFT, LoRa, QLoRa, quantization, double quantization of the quantization constants, all this good stuff. I love seeing that you guys are digging into the deets here. And how much of a on-the-fly debugging legend Wiz is. Yes, we know, guys. We know. It is really wild to watch it in person. What's happening when the model is thinking? I don't really understand this yet. Well, this is a great, great segue into the stuff we're talking about today. We're going to get a little bit into that, but it does take a little bit of kind of this test time or inference time optimization when we're doing the thinking stuff. Whereas when we're training it during training, we can do a lot. And we've done a series of events on large reasoning models in general. I would encourage you guys to check that out. And we will talk a little bit about it today. You'll see that we can really continue to abstract ourselves away from really worrying about this as we pull closed source and potentially open source in the not too distant future models off the shelf. A lot of great lessons. Just as always, you guys seem to be getting more interested in the internals of LLMs as we get into things like fine tuning and really dialing in the performance and cost for your use cases. This is a classic. This is something that comes after we build RAG, after we build agents. Shout out to everybody getting out there sharing. If you're not tagging us on LinkedIn or Twitter, we're not seeing it, but shout out to Lewis, shout out to Krishanu and Eric and Praveen. Great job, everybody. I love to see Praveen, love to see Eric getting the Sharon shoes on. Really great stuff. We do have another multi-agent framework event coming up. Originally, we had conceptualized this session as doing one or more additional multi-agent frameworks, specifically maybe AutoGen, AG2. With the advent of reasoning models, since we've started the cohort and really, really the entire world, DeepSeek and all the other, it makes sense to do what we're doing today instead. So if you're into learning about different agentic frameworks, we're gonna always kind of have that as a baseline on our Wednesday events. Those are things that are going to be much more accessible to you, knowing what you know now. Feedback from last time, we didn't have a ton of people provide feedback, but a lot of you thought it was very, very solid, good stuff. Love to see people catching up finally, or maybe let's say finally grokking the stuff we've been talking about all along. This was unfortunate to hear. I think this was only in one breakout room. I don't think that this was something that affected a lot of breakout rooms, but I wanted to shout it out. And if there's anything specific you think we can do in the future, let us know to help avoid this. The feedback was really good on the suggestion side. More post-midterm questions. Those of you guys that worked really hard. Unfortunately, we have to outsource this to office hours, etc. I feel like we should have explained this topic before. Hey, fair enough. It is hard to go end to end and figure out how to sequence curriculum. I still believe that this is the right move to not fall down this rabbit hole as we're trying to get the end-to-end understanding of the different patterns. So if you can convince me that we should move it up, I will, but I'm not yet convinced. And walkthrough of the traces. We're going to get into sort of production stuff starting next week. We're moving from prototyping into production, and you're going to see a lot more back-end Langsmith type stuff from the Wiz. So this is a nice segue into things that are coming up. Also, special announcement. We heard your feedback on networking, how you like the AIM games, how you like talking to people that weren't in your journey groups. And we're starting a new series. We're going to try this out. We're calling it the Fellow Travelers series. Okay, so we've sent some emails to most of you guys, and we've connected you with one person. And we encourage you guys over the next week, before next Thursday's class, to connect over email, to find a time to meet for, 30 minutes, and talk. Here are some questions that we'd like you to answer. We'd like you to sort of share whatever you learn, whatever you chat about in the AIE5 general channel, and kind of continue to get the networking vibe flowing. Now, importantly, I want you guys to understand that we tried to connect you guys with people that we thought you would have a decent vibe with, and we connected all the people that we thought would engage with this. And the way that we went about trying to assess who would engage is we just looked at who's been doing the work throughout the cohort. There's a lot of people that have sort of fallen off and not continued the homework after homework 1 or 2 or 3. And, we're not really sure what the status of those people are, or their bandwidth, or how much time they have available to do cohort related things. But those of you guys that have been keeping up with the course, that are on the path to certification, whether you've turned in your midterm yet or not, we thought you guys would definitely probably engage. So not promising that the person who we connected you with is gonna, totally email you back, even if you try, but we're gonna try this out. This is just a test we're doing. We wanna know what you think about it. We wanna kind of make it easier for the collisions and the connections in the community to happen in the cohorts. And so, we're excited to see how this goes. Let us know what you think next week, or on the feedback form for the homework that you'll submit in the next coming weeks. Okay, that's a little test we're doing. Thanks for joining us in the journey as we continue to try to make community connections here. All right, AIE 5, here we are. We're at the end of prototyping. We're talking agentic reasoning. We're talking advanced agents and reasoning. We are out at the edge, guys. What we want to understand is we want to understand hybrid reasoning models. I think this was a new term drop, like this week even. We want to understand types of agents that we can use and we can put into multi-agent applications that are useful today, like the most popular multi-agent application that all of the large model providers have started to build into their application, whether it's ChatGPT or whether it's Claude or DeepSeek or Hugging Face, all these people are going to be trying to offer this idea of a research agent, or Google with Gemini. And it's like, what is this really? Well, LangGraph just released an open source version of their deep research agent also just a few days ago. We're going to dig into it today. And it's going to be epic, okay? Just full disclosure, we're going to give Wiz the mic for an insane amount of time, and we're going to see how it goes. This notebook is legendary. We hope you guys enjoy it today. We'll also talk a little bit about evaluation strategies, just to show you guys that this is not figured out and it's not clear exactly what to do. Even as we've been in the cohort so far, the folks that are leading in eval for agents are asking for feedback from people building, shipping, and sharing like you. So, this is really a welcome to the edge, welcome to the end of prototyping, let's talk production kind of sesh. With that, I'd love to get into hybrid reasoning. Why am I talking about hybrid reasoning? Well, you guys, if you've been on social media this week, you probably have seen that Claude 3.7 Sonnet is crushing it. Everybody's loving it. What's really going on here? Well, it's the first hybrid reasoning model on the market. From the press release, can produce near instant responses. Okay, that's like a ChatGPT 4.0 model type response, or an extended step-by-step thinking, like more of an O1 or a DeepSeek R1 response. And API users like you guys today, because we're going to have you finally digging into Claude, can have fine-grained control over even how long the model can think for. So let's back up for a moment here. Reasoning is about thinking in a logical way. When we started our prompt engineering journey, we saw in the system prompt all the time, think through step by step. This is a really useful thing to tell LLMs to do. And this sort of gets into this idea of test time compute, or time or compute spent thinking at inference, at test time. We could also call this inference time compute, as opposed to training and as opposed to train time compute. And this is still a relatively new idea. This is from August 2024. Scaling test time compute was a paper from Google. And the thesis here is that humans tend to think longer on difficult problems. Maybe AIs should too. A month later, we saw OpenAI, O1, thinks before it answers, chains of thought, dope. And then we saw, of course, earlier this year, DeepSeek R1 has this thinking before it answers. Love this quote from Jay Alamar, the latest resounding beat in the steady drumroll of AI progress. Now, it's interesting that this capability of reasoning is actually kind of quite close to the surface of LLMs. And, we know that kind of from just playing with these from the last few years. The magic here is this idea of this chain of thought and this COT, these chains of thoughts. They are really good, and intuitively we know this. Right? This is the original chain of thought prompting paper from January 2022. Instead of Roger has 5 tennis balls, he buys 2 more cans of tennis balls, the answer is 11. Roger has 5, 2 cans of tennis balls equals this, blah, 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 da, da, and thus, and so we have the answer is 11. This is a much better way to demonstrate to the model in a one-shot, few-shot capacity how you want it to behave. And so it turns out giving the model steps makes for better answers. Well, better answers, that is, when reasoning is actually required. Enter today, literally today, right? Today. GPT 4.5 came out a couple hours ago. So, we are out here on the edge. Now, GPT 4.5 is not a reasoning model. Interestingly, they're talking about scaling unsupervised learning. This is a mystery masked term here. They're talking about pre-training. They're talking about unsupervised pre-training. Whereas scaling reasoning is about this chain of thought thing. This pre-training thing is obviously what everybody's been talking about forever. This, since we kind of started the journey here. Now, GPT 4.5 is this unsupervised learning scaling. This is that, not that test time compute scaling. This is that train time compute scaling. This is, of course, this idea of scaling laws in general that we hear so much about, right? This is the paper from 2022, Training Compute Optimal LLMs. Everybody's been talking about this for years. Okay, if you went to NeurIPS last year, or you watched the talk from Ilya Sutskever winning the award for the dope sequence to sequence paper from 2014, he's like, pre-training, game's over. Fossil fuels running out. Now, whether that's true or not, that's the sentiment in the industry. And so in the GPT 4.5 release demo, literally, they just pull up 4.5 and o1 side by side. This is important. I was talking to Wiz about this earlier this week. I said, this is basically what I do. I switch between the two all the time. And I was like, what, does Claude automatically switch? He's like, no, it's just a toggle. It just toggle, and you just pick which one. And I think that's the real question here. It's like, which one should you choose and why? Because it's not just OpenAI and Anthropic. Grok is getting in the game from X, right? Turns out they're in the dope camp. That's what I heard on Discord. It must be true. And moreover, if we look at what OpenAI is saying, actually, this is from earlier this month from Sam Altman. It's like they were going to ship 4.5, but actually after that, they want to go unify O and GPT series. They will no longer ship reasoning models separate. They're going to go hybrid as well. So, Wiz, I just want to get, your take on this here. Is this the new gold standard? The hybrid model? Is this what we're going to use for everything?
I mean, it's a good question. I think time will ultimately be what tells here. My gut feeling, let's say, right, is that we really want models that can do both things. So we only have to use one models, right? That's a classic. But as we develop better like LLM router technology, as we figure out new fun ways to do basically like stacking these models or selecting the right ones at the right time, maybe this becomes less important. But things like budget forcing and being able to choose when you're thinking versus when you're not is definitely at least in the interim going to be useful.
Mm-hmm. Yeah, I mean, if you're gonna try to build AGI, I think it makes sense to have the old hybrid setup, right? But if you're gonna just build like performant agent A connected to performant agent B connected to performant agent C, like, I don't know, in like a multi-agent setup, like maybe like an open deep research or something like that, maybe you can just choose the model you want to use for the job. Maybe the best model is a hybrid model. Maybe it's not. Certainly today, it's not always going to be the best, right? And then what's the status of open source right now? Do we have open source versions of these hybrid models yet? Are these coming?
Maybe maybe let's say that seems likely, right? Because we have it
Sure does.
from the closed shops, and we know that what happens is that if the closed shops are doing it, then probably there's some open shops that are doing it. And it's useful, right? Like inherently, this is a useful pattern, being able to choose when or when not to think more, or even just being able to choose how much to think, right? Like there are a lot of I would say problems, right, with the reasoning models in traditional AI workflows. They're slow, they think too much, they get confused, they're terrible
Hmm.
at instruction following, they're terrible at function calling, right? Like these are real limitations, and so having that toggle, it seems useful to me.
Yeah, yeah. Thinking too much, not
Yeah,
acting it out, just talking about it, it's
that's
like these
right.
are problems with humans just as much as AI. Just a clarifying question here from Lee in the chat. So when Claude 3.7 says they're the first hybrid reasoning model, what do they mean by this exactly?
I think so. Well, we don't know exactly. We
Right.
know what they've said, right? But what they said is that they are the there's not a thinking version of Claude and a not thinking version of Claude. Under the hood, it's all Claude, right? So we're left to determine exactly what they mean by that. But the reasonable assumption is that it's the same model, and then some process happens that makes it think. They imply that there is a component of like self-reflection occurring. So there's some test time scaling, right? But they're not. They don't. It's like they're a closed model shop, so we don't know specifically the scaffolding they're using. We're not quite sure. But the idea is that there's only one Claude 3.7. There's not like Claude 3.7 and then Claude 3.701 mini or whatever, like it's just Claude 3.7. And this can be leveraged in more than one way.
Yeah, so
Again,
like DeepSeek versus DeepSeek R1, OpenAI 4.0 versus OpenAI 0.1. There is no dichotomy with Claude 3.7. It's just one model.
It's just one model. Again, we don't know exactly, right? We don't know exactly how they're getting to thinking. They've said a little bit, right? There's some kind of post API system happening, right? There is some kind of iteration or loop or something that's occurring, right? And we can see that the thinking does occur. We get many thinking tokens, right? In real time, which they for now have decided to release, though they don't know going forward if they're going to keep that for future models. But we can assume that there's like reasoning mode and not reasoning mode.
Yeah. Yeah,
we
you
can
guys like the
assume
way
how they're
Wiz
doing it.
dances around this stuff technically. But yeah, okay, there's reasoning mode and not reasoning mode. Thanks, Wiz. Okay, so let's keep moving, guys, because we've got a bit more to get into before we introduce the code demo of the day. The real question here is like, well, which model is good at what thing? And what am I trying to do here? Like Wiz mentioned, instruction following, function calling, these things are not dope for reasoning models. And, remember in general, okay, what are we talking about? We're talking about reasoning. We're talking about agentic thinking, you might say, thinking in loops. Agents are useful when they're useful. They're useful when you need to determine the workflow of your app. And, importantly, I like people like Hugging Face that remind us like they're often overkill. If you can get it done with simple RAG, why not just get it done with simple RAG? If you need just quick API call to search, that's fine. So the focusing question here when you're building your apps is, do I really need the flexibility in the workflow to efficiently solve the task I'm trying to solve? And so when we think about top use cases for LLM agents today, let's remind ourselves the definition of agent we learned all the way back in one of the early sessions. It's a system that can leverage or emulate reasoning or equivalent to make dynamic decisions in an application flow. And so as we mentioned before, like our partners like LangChain and Llama Index, they tell us, hey, research is at the top of the list. Actually, it's been at the top of the list for all of the infrastructure providers, for all of their clients. And guess what? All of their clients that demanded this thing from consultants has now become a product from all the LLM providers. This is not rocket science to see the trajectory of how this thing goes. What's going to become a product next? How would I just look down the list here, Probably you shouldn't try to build that starting today. Probably one of the most competitive things you can do. Remember, LangGraph teaches us that agents with access to tools can solve problems. Enter Open Deep Research. Now, Open Deep Research was released from LangChain this week. They had a previous version of this. This one's more robust. It's a research assistant that generates comprehensive reports on any topic. Report Gen, what a classic. Just like OpenAI and Gemini. December last year from Google. Deep Research explores complex topics. Comprehensive, easy to read report. February, OpenAI. Deep Research. Do work for you independently, find, analyze, and synthesize, create a comprehensive report. Comprehensive report, comprehensive report, comprehensive report. So this is what we're talking about here with deep research. Now we can look and see what this is all about here. Okay, we give it a topic, we give it an outline. Ho-ho, and now we're off to the races here. We've got a planning and structure part of this. We've got a research part of this. We have sections that we're going to plan out. Each of these sections, I'm going to go into my research thing, and I'm going to do some searching and some researching, right? And I'm going to do that starting with the web. I'm going to go find some stuff. I'm going to reflect on it. I'm going to refine my thinking about it. And then I'm going to have that section. And maybe I'll actually think deeply about how I want these sections to be in the final report as well. So we can customize every aspect of this stack. We can customize the desired report structure. We can set the planner model, DeepSeek, R1, OpenAI O1. We can actually inject users into the flow to say, hey, is this a good plan for the report? Is this a good sections that I should be using? And let me do an iteration. Is this good now? How about another one? Is this good now, boss, right? Your little agent assistant. We can set the search API, Tavily, obviously, others, Perplexity. We can tell it how many times to search, how many times to iterate on each bit of the research. We can set the depth of the search. For each section, we can tell it how many iterations of writing, reflection, of search, of rewriting. We can do like every layer of the stack customization here, which we obviously can't do in the closed source models. And then, of course, we can customize the writer model. There are some baselines out of the box. Claude 3.7 Sonnet is actually the one that they use for the planning out of the box. Okay, because it's the little hybrid guy, right? So they use that. That came out 3 days ago, and they're using it in here, right? Here we are. Welcome to the edge, guys. Tavily, of course, and then Claude 3.5 Sonnet. So let's take a close look at this, and let's label some things here. If we look at each of these pieces, we see we provide the outline, we specify the planner model, then we get the reviewing of the plan, the providing feedback, the iterations. We can specify how many times we want to be doing searches, the kind of depth of the search. We can specify exactly how to do it, how many times we want to iterate on this. And then, importantly, we should take a closer look here. You guys asked for it earlier in the cohort. We have a reflection agent here, and we have a planning agent here. These are not new ideas, but they are important ideas. And planning and reflection are things that you'll hear said a lot. So plan and execute agents. This is from February 2024 from LangChain 24, right? This is a year ago talking about this. Kind of, paved the way for the research agents of the day. And so this idea is we can use smaller agents, right tool for the right job, to get us faster execution, So in a multi-step workflow, if we don't need to go to some big bad model and consult it for, we don't need AGI for everything. It's like, what do we need it for? Let's get a performant, purpose-built model for that. We can also get cost savings over, again, these larger models. We can be more domain specific. We can fine tune our models to make them really, really performant with our data and the input output we want for our reports. We talked about 10Ks the other day. Nick brought it up. It's like, well, what's your report structure? Okay, define that. Tell it that in your app. And then third, you can force the planner to think. They're saying things that we already know, okay, because this was a year ago, all right? This is from the blog. Now, you can look at a planning agent, and you can kind of understand it in broad strokes here. You ask a question, you give it a query, it generates a plan, it goes to the task list. Now, we might go to another agent and execute the task, okay, and then we go back, and we might do some replanning. Now, that's pretty straightforward, seems pretty, seems not that meta given the stuff that we talk about these days. Reflection is also rooted in these very simple ideas. Quote, reflection is a prompting strategy, also from February 2024, improving the quality and success rate of agents. So this is the idea that LLMs can assess their own thinking. LLMs can judge themselves. This is the LLM as a judge idea, or the self-refinement idea, right? This is the self-refined paper, March 2023. And so the idea is like, I'm interested in playing table tennis. Hey, I'm Shay, that's great, buddy. I'm sure that's a great way to, it's like maybe that's not what we want. And this is what OpenAI did in their demo today. They said, well, maybe that's not exactly what the person wants. Provide no information about table tennis or how to play it. That's sort of the assessment of itself, right? Hey, did you give it a good output? Was it engaging? Did you have user empathy, to pull a buzzword in from product, right? Did it really speak to them and make them feel heard? Well, no, not so much. Kind of blew them off, right? Hey, I'm trying to get into table tennis. It's like, yeah, okay, dope. And it's like, we can do better. Well, you can do better simply through self-refinement. This is the same idea as reflection fundamentally. Now, reflection, if you go and you just generate and you get some response and you reflect, you can say, okay, I'm going to critique myself. I'm going to say this was good, this was not so good, and then I'm going to try to do better. Now, this doesn't always work. In fact, sometimes it doesn't work because it's just not grounded in external data. It's kind of just caught in a thinking loop. Sometimes it does work, like in the paper, they cherry picked that idea. So this is the idea of a reflection agent, okay, with an X now, also from March 2023, verbally reflect on task feedback signals. What does this mean? Well, it means actually go to the world and do stuff and check and then revise. So you get the generator, you get the response, then you go and maybe you hit some tools. Then maybe you revise based on what you saw as output from those tools, and then maybe you get into this loop, and then maybe you're coming back. Now, of course, when we look at an open deep research, this reflection agent is clearly connected to external tools. So it's kind of like a reflection agent more than a reflection agent, right? And so, here we are. We've got all these steps. How do we put them together? That's the big question of the day. Buckle up, guys. We've got a notebook. It's got some serious lines of code. Hopefully, it's going to be a lot of fun. GitHub's coming in the chat. Wiz, take us away. Deep research.
All righty, we're going to research deeply today. Now, the first thing we're going to do is we are going to look at the app that we're going to be creating. So we're going to do the classic, demo where the first thing that we care about is, so how does this end up? So what we're going to do is we're basically going to take the system that powers this that you see on the screen, and we're going to convert it into a notebook so that we can run through each line. So like, let's say that we want to research about DeepSeek R1, right? So we're going to submit this request to our agent. Our agent's going to start generating a report plan. You can see that it does this in the little graphic here. You can also see what's happening on the right-hand side. Basically, the idea is that it's going to generate some kind of report plan, and then it's going to ask us for feedback. So we see here's the report plan, and then we are meant to say if this is good or this is bad. So we're just going to go ahead and say that this is good. We do so by passing true and then clicking resume. And we can see now we've entered the subgraph, right? So this is a, just like we saw before when we were using LangGraph, we have the subgraph, which is going to help, collect information, do some researching, search the web. That's the whole thing. That is the idea. So while this is kind of going, right, you can see on the right-hand side, especially you can see it if I zoom in a little bit more, but you can see on the right-hand side here, we have this idea of, we're going to do some research for each step. We're searching the web, we're writing a section, we're generating queries, we're searching the web, we're writing a section. Isn't that interesting? Once this is done, it's going to move us to the next few sections. So what we're going to do is we're going to unroll what's happening behind the scenes here, and we're going to look at exactly what this looks like in the collab or in the notebook. Sorry, you'll notice like the final result, right, is this DeepSeek R1 report that it's generated just like you would expect from something like deep research or deep search or whatever, version of this you're used to. Okay, so that's what we're going to build. Let's see now how we do it. So the first thing we're going to do is we're going to look at our notebook. You'll notice that we're in a local notebook. We don't want to be using Colab today. Such is life. Okay. When we go to the code, there's going to be a lot. Okay, it's going to be a ton of code. But the thing I want to really ground us in before we get feeling overwhelmed is that we've seen all of the constituent parts for this workflow already. We've already seen them, right? We're just kind of arranging them in a new order, and certainly we're arranging them more of them. So Greg already talked to us about this specific, diagram that we see here, where we have this topic outline, we do some planning, we create some sections. We're going to stop for human feedback, all super fun, cool things. That's it. Okay. When you are going through the code, keep in mind, again, this is just LangGraph, right? It's the same stuff we've been doing the whole time. We're just doing lots of it all at once. We're going to start, as we always do, with some API keys, classic API keys. We got to do it. Okay. The first part of our application, to the surprise, hopefully, of no one, is going to be our state. You'll see a big blob of text that's going to describe this state if you should wish to dive in more. But let's just look at it, right? It's not that scary. We have some section. Section is going to have a name, description, research, and content. Then we have some sections. A sections is going to be a list of sections. Makes sense, right? And then we have our search query state, our queries state. We have some feedback state. Then we have a report state input, our report state output, and then we have finally our report state. Now you'll notice that this report state is going to be, comprised of a few things, right? Our topic, the feedback, the sections we have, how many sections we've completed, how many report sections we should have, and then our final report. And you'll also notice that we have our section state. So we're going to have two graphs, right? Remember in that image that we had like a graph and then we had a subgraph. The subgraph is basically going to be the part that generates sections for us. Okay, so that's going to be our report state and our section state. Again, there's a lot of stuff going on, but like it's just a string, right? This is a string. This is a number. This is just a list of search queries, right? This is a list of section. It's not that insane, right? It's not that intense. But there you go. There's our state. So now we have our state. We have to build a bunch of helper functions or utility functions. This part's going to look a little scary, but don't worry too much about it. The big thing is we have some extractor for our configs. We're going to be using a config to determine which models to use, how many iterations to do, et cetera, et cetera. This is going to be for our search parameters. This is going to determine how we should search, what additional parameters we should include, depending on the search tool that we're using. We are using a bunch of different search tools potentially, and so we want to make sure that we're addressing them correctly. We have our deduplicate and format sources. So what this means is that deduplicate hopefully is straightforward. We're going to remove duplicates. And then, format, again, straightforward. We're going to put it into a consistent format. There you go. Okay. That's it. Then we're going to look at the format sections helper function, which is going to, spoiler alert, it's going to format the sections, right? We love it. Okay. The reason we have to do all of this prep work is because we're just, at the end of the day, we're passing around strings, right? Like to the LLM. We're giving it some strings, maybe a JSON blob if we're being fancy about it, right? But we're just essentially passing back and forth strings. All we have to do is basically take our formatted sections and pass them back and forth around to the LLM. Then we're going to have our traceables. Now, our traceables are something that we want to include in our trace. Let's go, right? So this is something that we want to be able to include when we're doing tracing. Tracing is important. It helps us debug. And the way that we get there is traceable. There you go. When we look at the actual tool, it just straight up calls like Tavili, right? We have one for Perplexity and Exa, depending on which search tool you're using. And then we also have one for Archive, which is going to be a little bit more, verbose, because we're going to extract some of this metadata and then format it into a useful format for the LLM. And then we're going to have the same thing again for PubMed, for when we're searching PubMed. Again, we're doing this extra kind of formatting in order to ensure that this is a consistent format for our LLM. Okay. Then that's all our utils. Now we have to create the report planner and some configurations. So in our default report structure, we're just going to provide what the report should look like. This is not like a hard and fast thing, right? This is just a let's call it a suggestion, right? For our model. We could certainly do even more code that would create like a structured report, but not today, not for now. Okay. Then we're going to look at the actual configs. You're going to notice that there's a bunch. For the notebook, we're going to ignore all of them, okay, except for Tavili and except for Anthropic. Everything else we're going to ignore, right? You don't have to ignore it, to be clear. When you build the app, right, you can use whatever you want. If you were to customize this, you can use whatever you want. But we're just going to stick with like the easiest case, right? Which is we're going to use Tavili, because we should already have a Tavili API key. And we're going to use Anthropic, which you should get because we sent an email telling you to get it. Okay. Anthropic, again, is the one that's 3.7. So Sonnet 3.7. Wow, so cool. Now, we're not going to use the thinking model by default, okay? Because you have to have some pro subscription or some such like that. So 3.7 Sonnet, I'll just collapse this. 3.7 Sonnet, we're not going to use thinking. If you have a pro account for whatever reason, you can append thinking just like this, right? Thinking. And then you can use the thinking model for the planner. We're just going to stick with regular old 3.7 Sonnet. And then for our writer, we're just going to use Claude 3.5 because it's dope. Everyone likes Claude. There you go. If we wanted to change which search tool we use, we could do this. If we wanted to add some additional configurations to our search, we can do this. If we wanted to increase the maximum number of depths that we went to, right? So how many times do we do that reflection pattern? We could do that here. If we want to increase the number of queries per section, we can do that here, right? So all of this is configurable. You can configure it as you desire. We're going to use this default for today because it's just the most straightforward. Again, if you want to use thinking, you'll have to add the thinking tag. There you go. Okay. So that's our config. It looks like a lot of stuff, right? But like all this is really saying is the report should have an intro, a main body section, and conclusion. And this is the search tool and LLM we should use. And this is how much thinky you should do, right? So we can, if we want to do more thinking, we would make these numbers higher, right? If we want to say search even farther and harder, we would just make these numbers higher, right? This is the idea of that test time scaling, right? Inference time scaling. We have a number, and if we make the number bigger, it will do more inference. Okay, that's the idea. There you go. Okay, so that's our config. It's pretty beefy, but straightforward. Then we have prompt templates. This is literally just a bunch of prompts, right? So all that's going on here is there's a bunch of prompts. You can see here for our report planner query writer instructions. You are performing a research for a report. Here's the topic. Here's the organization. This is your task. The query should be X, Y, and Z. Easy peasy. There you go. When you are using the prompts, right? These are totally editable. You can edit them to be whatever you want. You can make whatever changes you want. You can make adjustments. It really doesn't matter. All that matters is that you use the prompt. We have a prompt for each of the phases of our deep research flow. We have like our report planner. I want to plan for a report that is concise and focused. Very cool. A good report should have an intro, overview, comparison, conclusion. I bet you learned that in school, like classic report writing stuff. Okay, that's good. Then we have our query writer. They're going to write queries, right? And there's a big prompt that explains how they write queries. Maybe you think that the query should be more targeted or specific. Sure, you can just add that to the prompt, right? It's just a prompt. Then we have our section writer. Again, we can just adjust all of these length and style things. If we want to have, say, shorter, sections, we can say like strict 50-word limit, whatever should inspire you. You can change this here. For quality checks, right? Again, whatever should inspire you, you can change this here. We have our section grader. This is gonna, you bet, it's gonna grade our section. There you go. And then our final section writer instructions is going to be the thing that produces the kind of cleaned up sections that we're going to stitch together to create a full report, full overarching report. Very cool. So that's all of the prompts. There's a bunch of prompts, and they're quite verbose, right? So you can tell we're being very deliberate, right? All of these prompts are like, include no structural elements, right? Caps on the no, right? We have a bunch of repetition in what our goals are. We have this idea of quality checks. The kind of final takeaway here is that these prompts are super important, right? They're part of what drives the engine. We talk about it a lot, but like it's prompting all the way down. The rest of the application is just vehicles for these prompts to get to the LLM with the right context. Okay, so now we have many prompts. Now we need to create many nodes. Again, this isn't new, right? Like we've done nodes before. We've done nodes a bunch of times. This is the same old nodes, right? We're taking in state, we're doing some kind of modification to state, and we're returning that state. There you go. I mean, it's just nodes. There's a lot more code because we care about a lot more things. And we also are introducing this idea of a config. Now, the config is kind of like the state's state, right? So it goes beyond state. So where we have state, which is this object that we want to modify and pass around, we have kind of config, which is a fabric, right, of our application. It's the thing we set up above in the cells up above, and it can be referenced by all states. So the idea is that config is going to have some kind of generic, useful configurations. State is going to be the thing that we pass back and forth. There you go. Okay. Then, again, all that's happening in this node, right, is that we're going to get a bunch of stuff that we have in our configs, and then we're just going to call one of the tools that we're using. Really, I mean, this isn't even great code. It's literally just a huge if-else statement, right? Like, if we're using Tavily, we should use the Tavily search tool, right? If we're using Perplexity, you best believe we should use the Perplexity search tool, right? We're not even using like a switch, straight up just giant if-else block, because we have many different search engines that we could use. Then we're going to do some formatting for our system instructions, because we're going to have to pass this thing to our planner model. Again, if you include this tag, we're going to use thinking mode. And you might say, well, why are we using, or how do we use the thinking mode API, right? And it's essentially just the same as every other chat model, except we're going to pass in this thinking parameter, which is going to enable thinking, and it's going to give us our budget forcing. So budget forcing is useful. Basically, what it says is only use 16,000 thinking tokens, right? Don't use any more than that. Budget forcing is crucial because we don't want to, say, have runaway queries that use like 400 1,000 tokens or whatever stupid number of tokens you want to imagine, right? We just want to say like, hey, think, but like not so long that you're using more than 16,000 tokens, right? Like that, like you should be able to get the right thought within 16,000 tokens, my guy. Someone asked, why are we not using await for perplexity? Great question. I mean, basically the perplexity search was not set up as an asynchronous function. The specific reason for that is likely to do with their API and or the way that the LangChain interacts with their API. Perplexity is a very fun and complicated API, but basically the idea is that this perplexity search helper function is synchronous, and so we can't use await. What this does mean is that this will be blocking, right? So if you were to use this node in parallel with another node, you would have to wait for this node before executing the next node. Boo. But there you go. The node is blocking anyway, just due to the fact that we've set it up that way. So no matter what happens, we're waiting for this node to be done before moving to the next node. So the usage of async there is largely cosmetic anyway. Okay. Now, if we're not using our thinking model, we just straight up, we just use a regular model. So this is going to be the default in today's case. You'll also notice that, the thinking model doesn't support structured outputs. So we have to use this extra process that we don't have to use with our non-thinking models. This is going to be something you see all the time. Thinking models are terrible at function calling, and they're terrible at instruction following. So what we want to do is we have to coax the model a little bit more if it's in thinking mode versus if it's not in thinking mode. Okay. Then we add the generated sections to our state. Perfect. Next is human feedback. All this node does is ask the human if the human agrees with what the AI has come up with so far. If it does agree, good. We're gonna give this true, and then it's gonna go to the next session. You can see this here, right? If instance of feedback is a Boolean and feedback is true, then go to build section with web research, and then if it's anything else, so some string, right? We're gonna go back to the report plan, but we're gonna keep that feedback in mind, right? So the idea is that if the report outline is generated and you're like, I hate that report outline, why is it so dumb? You can give feedback and then the model is going to try again. There you go. Okay. Then we're going to generate some queries. So this is another node, right? Easy. They're all nodes. This is going to generate some number of queries for our usage in the next step. All it's going to do is ask the LLM to do this, generate search queries on the provided topic, and then it's going to store them in state. Let's go. Yeah, we have a question chat. That's great. Is it possible to set budget tokens in OLLAMA DeepSeek model? DeepSeek does not. So DeepSeek R1 and the distilled variants don't have native budget forcing. So the answer to that question is no. Though you can hack it by basically during decoding, inserting a stop think token when you've reached a certain limit, but you're going to have to build that solution. It does not come out of the box. Okay, so we have our generate queries node, and next is it's the search web node. Look at this thing. It searches the web with the tool that you told it to. That's all it does. That's it. It's going to increment the search iterations by 1 every time it's used. This is because, of course, we're limiting the number of times it can search. That's a hyperparameter, right? That's a parameter that controls the flow of this application. There you go. It searches the web. Then we have a write section. Write section is going to write a section. And then it's going to grade the section. And then it's going to write a section. And that's all it's going to do. Good job. Okay. You'll notice that if the feedback grade is pass, or our search iterations are above the max search depth, we're going to completed world, right? So basically, like, if the feedback that we get is like, hey, looks good, man, LGTM, right? Or we've already searched enough, we're just going to complete the search. We're done, right? If we haven't, we're going back to search queries. We're doing it again, right? This is a little loop that we're building in our graph. Okay. Then we have write final sections. This takes all the sections we generated in the node above, and it writes them out. Very good. Then we have gather completed sections. It's going to collate all these sections together, and then we're going to have the final report section writing, which is going to essentially just create a new set of or a completed set of report sections. And then finally, we're going to join them all together with our beautiful, double new line dot join. And then we're going to build that graph, right? So we have all of these nodes. And the way we build a graph is exactly the same as the way we built our multi-agent graph, our normal graph. We plop nodes down, we add edges. Now you'll notice that we have this section builder, right? And then we have this regular old builder. And in the build section with web research node, we have the compiled section builder graph. This is because we have a subgraph, right? Our section builder is a subgraph. It is a graph unto itself, right? So basically, it's going to be the workhorse that generates these, that uses search and generates these sections. And then our outer graph, the graph that wraps that, is going to be the thing that comes up with the plan, passes the plan to this subgraph. It's going to churn out a bunch of work. We're going to come back and we're going to compile all that hard work together into one beautiful output. All right. So now we're going to use, so conditional edge, great question. Conditional edge is going to go to a different node depending on a condition. So in this case, right, we're going to go from gathered completed sections and either go to initiate final section writing or write final sections depending on some condition. There you go. Good question though. We're going to add one new thing to this LangGraph implementation, which is the idea of a checkpoint. So the reason we want a checkpoint is because we actually have to interact with this thing, right? It requires human feedback. So we've got to be able to like run it for an amount of time and then stop, provide feedback, and then continue on, right? So we're going to use this checkpoint. All it does is it saves the execution in memory. It's associated with a thread. A thread just has a specific ID. It's not too complicated. The idea is that we want to save what's happened so far so we can carry on, right, after we provide feedback. And that's what this is going to do. You'll also notice that we have pretty prints. The pretty prints are just going to make us not hate our lives when we scroll through this, scroll through this output. It's just too much. And basically all this is going to do is it's going to run up until it hits that interruption, which is our human feedback node. We're going to see, hey, this is the plan. Do you like the plan? We can either choose approve the plan, where we're going to resume equals true on our graph. That's associated with the thread we set up above, right? So when we kicked off the graph, we gave it some thread ID. And if we don't like it, we can use provide feedback to provide feedback and then kick off this process again. For simplicity's sake, I'm going to suggest by default you use approve plan. You'll have to do some additional writing of code if you want to provide feedback. But when you use approve plan, it will then go through the rest of the nodes until you get the final report. And the final report is going to look like this, like we saw in our initial demo of this application. And that's it. Now, it's a lot, okay, to be fair. It's a lot, but that's it, right? It's all stuff we've done. It's adding nodes. It's connecting those nodes with edges. These functions are just doing things like search the internet, right? Take this result and make sure that it's formatted properly. Like there's nothing really complicated happening here, except that when we get all these parts churning together in concert, we get like a pretty decent report, right? Like we get this this fact that it's super cheap to run this thing. We get a bunch of really interesting pieces of information, and there you go. Now there's a final activity in the notebook, which is just going to be discussion-based, theoretical, right? Which is how the heck would we evaluate this thing, right? Like, how do we push this through Ragus to evaluate if this is, like, good or not? Because I can read this report and tell you at least most of it is largely accurate, right? But like, how do we actually systematically evaluate this kind of structure? There is, to preempt, like, well, what's the right answer? There is no right answer yet. We don't even know, right? There are people that are working very hard to figure out if there is, how there is, et cetera, et cetera. But you know, right now it's basically just an activity for you guys. How would you approach evaluating this? How would a report be deemed good or not good? Right? There you go. Okay, so that's what we're doing. That's what we're doing today in our breakout room. Just working through this one big beefy notebook. Also try out the app if you want. There you go. All right. With that, back to Dr. Greg.
Yes. Okay, Wiz. I'd like you to keep your screen up for just a minute
Yep.
because we got one question in the chat here. Like, it does say from the deep research repo that we can put a human in the loop here. Like, where exactly is that in the code that we could sort of, you know, exit and put a human in and make it more of a state machine setup than an autonomous setup?
Well, this is exactly what we talked about, right? So we kick the graph off. That's going to go until we hit this feedback step. It's going to have a feedback request, going to pause the execution. Then we're going to go ahead and either approve the plan or provide feedback. And then we have to either execute approve plan or provide feedback. Approve plan means it's all good. And then, you know, provide feedback means I need you to change something. But this is where it happens. So basically, this graph is run in two stages. The first stage is up until the feedback. We pause for feedback. And then the second stage is once we have provided that feedback, and I'm going to recommend you just approve the plan because it gets more complicated in the notebook if you provide feedback.
Yeah. Always got to pause for that feedback. We know all too well. Wiz, thank you so much. Wow. So guys, that was open deep research completely unrolled into one notebook. You will not find it in the repo like this. This was a Wiz special. We're going to take a quick break. Whoo, that was a lot. We're going to talk about a little bit more before we have an extra long extended breakout room today. Shake it out, guys. Come back in 5. Be ready to get after it. If you want to stick around and ask any questions, feel free, especially those of you that were crushing the chat. Let's go. 5 minutes. Break it out, shake it out. We'll talk a little bit about eval, and then we'll get back after. Now that we're back from break after we've seen the unrolled open deep research, it's time to think about evaluation for a minute. We always must build and evaluate, okay? This is how we can get our baseline. This is how we can keep building, shipping and sharing like legends. When we ask a query, let's go to a simple agent and remind ourselves what happens and what we can assess and what we know we can assess today. Well, we take an action. We're going to act. We might think about this. We're going to generate maybe some response. Maybe take a few actions with a few different tools. One thing that we can do is we could say, well, did I call the right tool for the job? Very important question to ask, depending on your application. We might also say, like, well, did I actually help the user? Did I help them solve their problem? Did I help them achieve their goal? And I could also like just look at the trace. I could look at the big list of messages. I could look at the reasoning, okay? The reasoning that the agent is doing because the prompt keeps changing, let's say. Is that about the reasoning path that a human would take? Is that what I want it to do generally? Which spots did it mess up? And why is that important? Okay, let's zoom out. Oh, what have we got here? Well, let's take these 3 questions and try to apply them to the deep research thing we just built, which is obviously not just one agent. Well, I could say, did I call the right tool for the job? But that's kind of dumb because I told it, well, here's the tool, use it for the job. I could say, like, look at the trace. Am I doing planning right? It's like, well, maybe I specified exactly what I wanted the report to be. Maybe that's not. Did I help the user achieve the goal? Okay, well, I mean, how about you just ask them, you know? How about you figure out how to define this if you don't want to just ask them? I could also kind of try to take this a little bit to the next level because, I mean, look, there's another agent down here that we're just ignoring, right? I could also say for that one, does it trace? Does the conversation thread look reasonable? Does it look like what I would do if I was doing research on this? Was it robust enough? Did I get enough sources? Did I leave anything out? You know? Think about when you've used O1 or reasoning model to help you do research so far. Does it always perform perfectly? How would you like it to perform better? And of course, at the end of the day, helping the user achieve the goal is obviously the goal. Well, we also can sort of stay rooted in this space of emerging metrics that we started talking about already that may or may not be all that important, right? Obviously, tool call accuracy, we just talked about it, probably not that important right now for this one, unless we add more tools. What if we added Tavily and Perplexity? Well, when should I go to which one? For real though, like hard questions. Or if I wanted to say, are you staying on topic? Bro, I might want to say this for a particular part of this research. And, this gets us back into topic adherence, gets us back into precision and recall. I know some of the discussions happening last time. We're down in the weeds on this kind of thing. This gets us back to some of the core fundamental ideas. You can sort of go all the way back to classic ML. But you might say down here, when I'm trying to do research, I'm trying to search and research, and I'm trying to stay on topic, am I staying on topic down here? Or not? It probably matters. And since we've started this cohort, this is a post from today from the co-founder of Ragus. And I hate to be so hypey today. Like, we're trying not to be super hypey. Deep research is an important application. Agent evaluation is important. Here today, gone tomorrow is not the kind of stuff we want to be teaching. But this is literally a building in public issue that Shahul and Jitin from Bragus are trying to figure out. Literally. Well, here I have some more ideas based on talking to our customers, right? Path efficiency, progression rate, consistency. He's trying to solve the meta problem, the general problem. That's very, very hard. How about you think about trying to solve this? How about you think about it today? How about you sort of embrace being out here on the LLM edge? You've made it, right? We made it all the way through prototyping. You know enough now to be able to, like Dirk did earlier in the chat, right? Identify that deep research is just a multi-agent application with LangGraph, no problem. Probably build it with another framework if I really wanted to. I got the core patterns. I got to do some evaluation. What do I want to evaluate exactly? These are questions that all the AI labs are working on right now. If you figure it out, go pitch it to Sama, right? Go pitch it to Elon. Go pitch it to somebody that runs a big AI lab. Go pitch it to Darius. Dario? Amade at Anthropic. Bet you could get a job, So we're trying to give you industry relevant things to work on, to think about, and we think this is one of them. So we're going to give you some time to work together in breakout rooms today with your peer supporters, with your journey groups, work through this implementation, talk about the evaluation. If you come up with any genius ideas, maybe you start building, shipping, and sharing like a legend, and who knows where you'll be in a year. That's the task for today, guys. We'll be back in 35 minutes, and we'll have a few minutes for Q&A at the end if you want to discuss with the group or you want to share any big breakthroughs that you guys make together as a group. Work through deep research. Let us know what you think when you come back. Have fun with the journey groups, guys. 35 minutes building and evaluating very, very complex agentic reasoning applications. This is the end of prototyping. enjoy the last breakout room. See you soon. At the end. Welcome back from the breakouts, everybody. We hope that you guys had a great session with your journey groups. You know, we were thinking, Wiz and I here about the essence here. And, you know, I think the key here is that you really have already done all of this. We didn't really learn anything new today, but now, 7 weeks in, you guys can create deep research, open source yourself. You can literally prototype anything, like as good or up to snuff as anybody is out there prototyping with these newfangled tools. Now, of course, you're not going to be as good as like the Wiz and people that do this all the time, and you're not going to be as fast, but the core concepts, the core code, the underlying understanding, you're there. And, you know, we really are building everything all over again, all the time. And I want to just like take a moment to just pause on the 7 weeks and this meme that we have on this outline slide here. The idea here, of course, is that there are a million trailheads that we've come across. And we've come across so many rabbit holes that we could fall down, from classic ML to classic software engineering to this, that, and the other. But to really create end-to-end products with AI and with engineering, we have to bring in the expertise that we want to combine with this. We have to bring in not only domain expertise, but, you know, many of you have product expertise. Some of you have design expertise. You know, some of you are worked in DevOps. Some of you have actually been software engineers, principal engineers for many years. Some of you have led engineering teams. You have to bring your own special sauce to then take all of this and to build the right things at the right time for the right place to maximize value for yourself, for your family, for your community, and for your company, and for the world. So, you know, this is the end of prototyping. And next week, we start talking about production. You know, next week, we go to prod. And that means that we're sort of done being like super fancy and like newfangled and super edgy. Like, this stuff doesn't get as much press, but it is equally as important. How do we make the stuff that we're building now more reliable, more scalable, more secure? How do we allow ourselves to put proprietary data in? How do we actually set up scalable endpoints? How do we do all of this in a way that really aligns with best practices, and we can hand off to our ops team, we can hand off to our engineering team, and they'll be like, hey, you know, respect. I like that. And you can teach them something, and they can teach you something, and you can start to continue to infuse your organization or wherever you want to go next with these tools and technologies. So, you know, continue building, shipping, and sharing this week. You know where to find everybody. It's, wow, it's Thursday night already. And there's a lot going on Friday. If you want to talk more about your projects, about anything, go find a peer supporter. Consider attending, you know, things like our Wednesday events or watching them after if you're interested in the latest multi-agent frameworks or the latest tools and technologies, because we're often covering those. And of course, you know, consider that we will, in just a few months here, be in Toronto. Many of you are already in Toronto. We'd love to see you there. And with that, I want to also remind you, you know, Vincent's talking about advanced chunking, advanced RAG, advanced retrieval. None of this goes away. It's kind of boring compared to what we did today, but it's also super relevant for industry. And with that, it's time for some feedback, everybody. Don't forget to join me on Monday, Build, Ship, Share session for a little accountability, feedback form in the chat. Let's get this song 2 rocking and rolling back up for 2 minutes. All right, guys, it is 2 minutes to the hour. You know, I'm going to go ahead and call it here. You gave me a couple extra minutes on Tuesday, and hopefully we're in a good place. We're all squared up heading into production next week. I do want to remind you guys that if you did get an email for a fellow traveler virtual coffee, now is a great time to chat with folks that are on the path with you. If you were not somebody that got an email, but you want to be, let us know. Let me know, let Sriracha know, let your peer supporters know. And if you guys like this, we're going to do a couple more rounds of it and just try to get the networking flowing. There are some folks from around the world that join us async that should be pretty fun to talk to. You've probably never seen them in class. So it'll be a nice, hopefully, vibe and mix. Let us know what you think. You know, enjoy the weekend. You guys have done a fantastic job over the past 7 weeks building, shipping, and sharing. The next 3 weeks are icing on the cake. So, you know, well done, everybody. We're looking forward to seeing what you build, ship, and share for demo day. We'll see you on Tuesday to kick off production. LLM applications will be shipped to prod, and we will get for real with our AI engineering in ways that many of you already know, some of you not so much. If you're a software engineer, you're coming in and you're like, hey, I already know a lot of that. If you're a data scientist or a leader that's never been an engineer, you're coming in, you're like, wow, this is new. More trailheads, more dopeness, more bingo cards. Shout out to everybody. Great job. AIE 5. Have an awesome weekend. We'll see you soon, guys. Session 15, prod on Tuesday. Enjoy your evening. Enjoy your weekend. We'll see you soon. Bye, everybody. We're going to vibe out.
Bye, everyone. Have a nice
Bye.
weekend. Bye.
Bye.
Later.
Later. Deuces.